Okay, investigation 1.3. So this would be the last lab in the first chapter. This one's a pretty good one. Notice this is almost the same setup as last time, but now I have 2 Photogates instead of just the one. To make sure that you get positive times on your data collector, just make sure whichever one is plugged in here is Photogate A, whatever one is here is Photogate B. If for some reason that got switched up, whatever, and you're getting negative times, students should probably know you can't really have a negative time. You can just flip-flop which ones these are plugged into, and that will fix that. So no problem there. The main note to make about this, if you read this, is each lab station is going to have this set up to a different peg height. So you'll have some that are low, some that are high, because it's going to ask students to make a prediction, and this might be good to do as a class before you have them start, which one is going to get the higher speed. Intuitively, I think students are going to know the higher up they are, the faster the speed that they're going to get. So let's go ahead and take a look at what students will be doing for this one. Students in this one are going to be dropping this, and I'll go through both of these Photogates. If you haven't already taught students how to use this, there's actually a good part of the lab in section 3 that talks about variables and how you can control for it. So if students haven't been using this, and when they go through for the second trial, having them use this will get them much better results. Let's take a look at what the data looks like when we send a car through 2 Photogates and how do we use that. So I'm going to go ahead and let this one go. You'll see that I got a time for Photogate A, time for Photogate B, and then a delta T A B. That might be a good time to talk about a little bit of Greek. What does delta mean? It's the change in time to go from A to B. And so what this is going to be able to give us is an average speed from here to there. The time A and time B is similar to the last lab. That's just, I would be able to calculate my absolute speed here and my absolute speed here using those, but using this delta change in time from A to B, I can find my average speed that the car traveled here. And so what that is saying is from here to here, it took that much time. So distance, I went from 35 centimeters up to 70 centimeters. So my distance is 35. My time is 0.355. So distance over time, 35 centimeters divided by my time gives me my speed. And it might be important to know, if I keep it in centimeters, my speed should be in centimeters per second. Or if your class is good at moving decimals, I can convert this into meters, 0.35, and then it would be at meters per second. It's just going to be a different number. However you approach that for your classroom is totally fine by me. The students will run through a second trial of this after you have a class discussion about how you can control to make sure that these times are as accurate as possible. They're trying to get these to be similar through multiple trials. And so that's what the second trial for this one is. And then the last part of this is just some of them analyzing questions. So not a very complex lab. You will have to explain this time A to time B and how to use that to calculate the speed as opposed to just using one of those, but pretty good lab overall.